All right. Hello, everyone. Welcome to today's free webinar, Quality and AI-Based Systems, with our guest speaker, Adam Leon Smith. I'm Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has delivered insight and confidence to hundreds of clients around the world. We have a team of international consultants that deliver customized training, consulting, and expert services to companies that are looking to improve their test and quality assurance practices. And today we welcome Adam Leon Smith, as I said, as our guest speaker. Adam is CTO of Dragonfly and is focused on testing, quality, and AI. With 2 decades of experience in environments, development, testing, quality, and project delivery, in addition to commercial experience, he is the chair of the British Computer Society Special Interest Group in software testing and works with international standardization committees developing AI and quality-related standards. AI is a complex topic and is the biggest technical renaissance to impact testing for at least 2 decades. Today, Adam will talk about intrinsic quality issues with AI, challenges in testing AI-based systems, and new techniques and methods. In addition, he will cover emerging AI-enhanced testing tools that are yet to get much coverage. Breaking news here. If you have any questions during the course of the webinar, you may submit them throughout the presentation, but please note that they will be answered only at the end. So let's jump right into it. Adam, take it away.
Hey Rex, thanks for the intro. Hello everybody. Good day, good morning, good evening. So I'm going to give you, I'd like to give you a deep dive into AI testing and quality today, but we've only got a short period. So what I'm really going to give you is a whistle-stop tour of the issues relating to quality testing and AI, the opportunities, some of the work that's going on in terms of education and in terms of standards. So I think everyone's becoming increasingly familiar with the concept of AI. So I'm only going to briefly try and define what it is for you. For business, certainly it is the new must-have for every business. Many different sectors, many different use cases where people are looking at either improving their business model or reducing their cost base using some kind of AI. It's used throughout your phone, it's probably used in your home, and it's most certainly used in the workplace. It's loosely defined as applying knowledge to make decisions, in contrast to explicit logic in the way that we're used to with traditional software. And I'll cover that a bit more in a minute. There's problems with verifying AI through testing, but there's also benefits to using AI within the testing process. And you'll hear a lot about AI in the context of trustworthiness, societal concerns, ethical concerns, and the like. AI changes the way that we deliver systems, changes the capabilities of systems, and changes the characteristics of systems in quite significant ways. So briefly, I want to talk about the difference between traditional software and machine learning. Machine learning is certainly not the only type of AI, and most complex AI systems involve more than one kind of algorithm, some of which probably won't be machine learning. So with traditional software, we specify code and we specify input data. We then execute that through some kind of dynamic process, which typically produces some kind of output data or some kind of output interaction. In contrast, when we build a machine learning system, we have input data, we have model parameters, which then go into a model process, which gives us a model, but then at runtime, that's joined with explicit logic, traditional software, and input data to create output data. So the whole way that we create and execute systems has changed in quite a subtle way. And that subtle way is that the behavior of the system is based upon the data upon which the machine learning components were trained upon. So it's not just QA engineers that think it's difficult to test machine learning or that it's an interesting topic for research. There was a detailed survey done in Japan involving 278 machine learning engineers to identify the biggest new challenges they had implementing and integrating machine learning components. And the 2 biggest problems they listed were decision-making with customers and testing and quality assurance. They also identified the lack of a testing oracle and the imperfection of machine learning systems as a key cause for the difficulties in testing and QA. I should say there's a link on the bottom. I will post the links that I've referred to in this presentation on my Twitter feed a little bit later on. So if you do want any of the links, make a note of my Twitter handle, which is in the bottom right. So I'm now going to take you through what I think are the top problems relating to testing, quality assurance, and AI. So the first one is that machine learning can be defined as automation with less or no specification. If there's less specification required to produce new systems, how are we going to verify those systems? If we aren't going to explicitly say what the software is supposed to do, how are we going to know whether that software is correct? If we're writing a system to find an answer we don't know, say we're writing some kind of model to predict which stars may have alien life on, we're not going to know the right answer to that question. So determining the oracle, determining things like test, pass, and fail is a very complex topic. If we want to measure the coverage of our testing, in white box testing, we can measure things like line of code coverage, statement coverage, decision coverage, condition coverage. That's actually completely gone when you look at the decision-making process of something like a neural network. So how do we measure testing coverage in a world where data defines the behavior of a system, not logic? If systems optimize themselves dynamically, do they do so while we're testing them? And how might my tests influence the quality of the end system? For instance, if you ask a chatbot lots of questions repeatedly in a test environment, the chatbot will become almost biased towards those questions and respond better to those questions in a production environment unless the model is bootstrapped. If the system is designed to mimic humans, to mimic human qualities, which AI systems often are, then how do we define human qualities and capabilities? If I said, go and make an ethical chatbot, how would you go and define all of the requirements required for something to be ethical? Which system of ethics would you use? One of the real problems we've got with AI these days is it's typically what we call narrow AI. So AI that's very good at solving a very specific problem. When it's moved into a different context, a different problem space, we find that it often performs very, very badly. If that problem space has changed and the model isn't optimized to be able to deal with generalized problems, which they usually are not in 2020, then all sorts of problems can happen, transferring the context of operation of a model into a different problem space. Bias is a huge topic that you'll hear about. It's a statistical topic, it's a data topic, it's an ethical topic. All machine learning models are biased. They're biased sometimes in good ways, sometimes in bad ways. Understanding this complex topic, what you may need to consider and look for in your testing is one of the key topics within AI and software testing. You don't just go live once with AI systems, usually. They are continually optimized and revalidated. If machine learning works by drawing correlations and finding patterns in data, one thing you have to be aware of is that those correlations in the real world, in the ground truth, will change over time. An algorithm that predicts footfall in supermarkets will not be working very well in a coronavirus lockdown area. Another of the problems we have is defining the difference between ethics, fairness, and requirements for a system. There's a lot of issues with AI and ML that hit the press. Defining ethics and fairness is most certainly not a tester's job, but it is an attribute of the quality of any AI system. What if it's trusted too much? We've all heard the examples of people driving self-driving cars who get distracted and start looking at their phone and don't see things that are happening on the road in front of them. Becoming biased towards how software behaves is not just a problem that exists in self-driving cars, it exists wherever machine learning exists in systems. Humans implicitly start to trust recommendations that machines give, and this can have very interesting effects during testing cycles, user testing cycles in particular. What if it can be tricked? So there's a number of different ways you can trick an AI system. You can interfere with the data used to test it, train it and test it, I suppose. You can introduce things like perturbations in input data. So you may have seen pictures. You can change whether an AI thinks a picture of a cat is of a cat or whether it's a dog by changing just a few pixels in the image. So there's a number of different security concerns and security vulnerabilities that require testing as part of machine learning and AI systems that didn't exist with traditional software. So that's just a really quick whistle-stop tour of some of the top 11 AI quality issues that there's active research going on around. One of the things that's going on is a revision of the Square series of quality standards. So I'm the editor of the extension to Square that's going to define what all these characteristics are. How do we define them, and how do we define measurements for them, and start to understand AI products in a consistent, measurable, verifiable way. Some of the things we're thinking about some of you will be familiar with ISO 25010, which is a standard that allows us to talk about usually non-functional characteristics of software when we're talking about things like quality and testing. Some of the characteristics that might matter more with an AI system might be the ability to learn, might be its ability to be robust against failure when people are trying to trick it using different data sets and injecting pixels to fool a corporate KYC system or something. Trustworthiness is an interesting topic. Is trustworthiness different to quality? Probably just by the difference in terms of whether things are specified as requirements and whether they're explicit expectations of people that are building a system versus the general public. Controllability. The smarter AI gets, the more we have to think about whether we can actually control it. Just the way we think about observability, by the ability to actually see what it's doing now. Explainability is a huge topic, probably more for defect management than test management, but explainability is the ability to explain why a system took a particular decision or made a particular recommendation. In the most extreme context, I've heard people talk about this in the context of medical robots, where a robot is administering health treatments using AI to, say, an elderly person. Explainability features are things like a button on the robot that you can hit that tells you why it did the last thing it did. Boiling this down to something as simple as a credit loan decisioning system used by banks today, if that's using machine learning, can people really determine why that system recommended a loan for one person and not another person? Correctness is something that needs to be thought about more in terms of things like false positives, false negatives, positive accuracy rate, negative accuracy rate, rather than simply a pass or fail metric. Completeness for unseen situations is going to be really important with AI and ML. To what degree is the system able to handle a very different context and problem to the one that was expected during testing? Systems being free from bias is an important quality that people are very focused on. This doesn't just mean ethical bias, but as I said before, it also means statistical bias. Bias is a quality issue just as much as it is an ethical issue. If something is making incorrect predictions, any business is going to want to know that. If something is making incorrect predictions that are unethical, any business is going to want to know that and make sure that that isn't something that ruins their reputation. Privacy and ethics, finally, are huge topics in themselves, but these are all some of the things that are being considered in terms of how do we build a consistent international quality model for AI systems. But as I talked about before, AI can also be used for supporting testing and quality processes. Some of the examples include test data creation. So the ability to generate test data using things like genetic algorithms allows you to create lots and lots of test data with slight variations. But data synthesization is an AI technique that is used to inspect, say, your production data or some real data, and to generate new data, for example, test data, that has the same statistical properties, it has the same profile, but it isn't the original data. It isn't confidential, it isn't private, it isn't production data. AI systems are in use for defect triaging and analysis. Things like identifying duplicate defects, things like identifying the right person to fix a particular bug or to test a particular, retest a particular bug. These things are much easier with AI than they are for people. And some systems give really good results in these contexts. Anomaly detection is something that's used particularly in visual testing, visual regression testing, identifying where test results deviate significantly from expected results versus only a pixel or two. Optimizing tests, selecting tests, prioritizing tests is another area of focus for AI automation, AI testing, sorry. Efforts estimation, predicting how many story points belong to a particular JIRA, how many days it will take to test a particular test plan or issue ticket is something I've heard about people doing. But the most common area I hear about people using AI in testing is for test automation. So either using ML on the object recognition, using computer vision, identifying objects using what they actually look like rather than some ID tag that Selenium finds. And finally, the identification of visual bugs. That's kind of tied in with anomaly detection. These are the main areas where people are investing in AI-enabled testing, but there is significant risks associated and challenges identified with AI-enabled testing that I won't get time to cover today. And here's one example to leave you with, something you can all go and do now. If you haven't seen this website before, it's really stunning. This person does not exist.com. Next time you need a face for test data, go to this website, and rather than taking a selfie or taking a picture of your testers, you'll find you have a high-res image of a unique person that does not exist. This is the sort of quality of test data that AI can generate these days. So some of the tools on the market, as I said, there's a lot of people working in the visual test automation, functional test automation space, and test generation itself. That's one thing you can do with ML and AI is take an existing system and generate a significant amount of new tests that reflect the current behavior of the system. So when you then get a new version and want to quickly regression test, you can do that. But again, that's very different to traditional test automation approaches and comes with its own risks and challenges. The certification that's available from ISQI, created by A4Q, is the AI and Software Testing Foundation certification. Some of the topics that it covers is, first of all, the background of AI. There's a whole day of the background of AI and what's the difference between symbolic and sub-symbolic AI. Effectively, what's the difference between machine learning and everything else? This course covers the key algorithms and technical approaches from the perspective of a tester. You don't necessarily need to know every possible hyperparameter on every type of neural network to test a machine learning model, but sometimes it's useful to understand what the quality concerns might be relative to each other. The limitations of AI are a key thing for testing and quality professionals to keep in mind and to understand, because there are a lot, and that's how we need to gear our verification and validation strategies. I talked about some of the general quality issues with AI, and a number of those are covered in the course, as well as specific functional testing techniques that you probably won't have heard of. First of all, how machine learning models are trained and tested by data scientists and how that interacts with the wider testing processes, but also metamorphic testing, A/B testing, expert panels, and external validity testing. It covers specifying acceptance criteria in probabilistic ways and reporting test results in statistical ways. And finally, it covers how to apply traditional testing levels to an AI system. Some of the work that's going on in the standards community, also there's a lot around quality and testing. So there's a new version of, a new part of ISO IEC 29119, a technical report coming out probably later this year, specifically about testing AI-based systems. There's work going on, as I talked about before, to update the SQUARE standard to handle AI systems. And there's related topics underway that aren't directly related to testing, but certainly relate to some of the quality issues I've talked about around bias, trustworthiness, robustness, risk management, and ethical and social concerns. And these should all be coming out within the next year or so. So that's my whistle-stop tour of the AI testing and quality world. As I said, I will tweet out some links after the session, but keen to go to Q&A.
All right, excellent. Thank you, Adam. Let's see. I actually had a question. Could you talk a little bit more about the synthesizing of test data, because this is very interesting to me. The traditional approach, of course, is to take production data and try to anonymize the personal identifying information that's in it, and that is quite problematic. You have issues with reversible anonymization, potentially reversible anonymization. You have the changing of the test properties associated with the data so that you're not testing the conditions that you thought you would, so forth. So maybe you could say a little bit more about how that process works.
So it essentially works by, first of all, you kind of tell it what you want to conceal, if you like. You tell it this field's a unique ID that has to match the system over here. You don't change that one. And then you have a set of other fields. Those fields are profiled just as a machine learning engineer would when they were analyzing any kind of data set. And the sort of thing you'll look like is the occurrence of different fields, the correlation between the presence of values in different fields and things like that. So then you can, once you've built up a profile, then you can generate an unlimited amount of data that a data scientist wouldn't be able to tell you which was the real data set from looking at it.
That's interesting. Yeah, I got a question coming in from somebody, but they use the chat panel rather than the Q&A panel. So I'm going to ask people to use the Q&A panel. So we have a question from William, and he says, are any standards organizations addressing using AI to plan / automate / execute tests?
It's under consideration. And if that's something you're interested in contributing to, I would encourage you to reach out to your national standards body to see how you can participate. But that is under consideration at the international level.
Interesting. Okay. The question here, will AI replace software testers?
So,
job going away.
Not soon. What will start to happen, I think, is we'll start to see things edging away at the more menial things we do, not just at the sort of test analyst level, but also at the test manager level. I talked about things like assigning work out during this. And ultimately, AI is never going to be able to talk to stakeholders, critically assess what a software product needs to do, think of all the ways it might break. I think by the time we get to that point, AI will already be writing the software, and testers or developers will be unnecessary.
So someday, but not soon. What is the role of a tester in regard to ethical issues?
The same as everyone else, and also the same as testers normally. So the same as everyone else, and that anyone working within the IT profession has kind of a societal responsibility, possibly belongs to a professional organization with a code of ethics. Different to everyone else, but the same as traditional testers, in that testing is all about giving people information, and it's all about doing that against requirements. I'm not suggesting that testers should go out and do things without requirements, but they should be aware of some of the context of some of the ethical requirements they might receive, and be prepared to give stakeholders, managers, information about the conformance of the system against those requirements.
Okay. Where can I find out more about AI testing?
Well, as I said, ISO IEC have a technical report coming out. There's actually quite a lot of things on YouTube from various people, like Tariq King in the US, like myself. There is obviously a course which is provided by ISQI and A4Q.
Yep.
It's a really interesting topic. Also, if you want to follow me on Twitter, I tend to tweet about it fairly regularly.
Great. Guillermo has a question. Says, how do you test the correctness of an AI system if the system itself cannot show the decision tree?
Well, the system usually can't show the decision tree. And that's what explainability is all about. So you can't do the equivalent of black box testing and understand all the different logic paths through. You can do other types of testing that are kind of novel, like metamorphic testing, like A/B testing. You can do functional testing with probabilities as well, because ultimately that's how machine learning is, making the logical decisions. It's using probability and maths.
All right, great. Let's see, any more open questions? Looks like not. Any final words from you, Adam, you want to throw out there?
No, it's a huge topic to rush into such a short time. As I said, there's lots more information out there. There's some really good opportunities to learn more about this exciting emerging topic that really has quite a significant impact on the way we verify and validate systems.
Yep, great. Well, thanks very much for doing the guest webinar here. Appreciate you taking time out of your day. I realized that it didn't interfere with your going to the pub, since no one's doing that now in the UK. When strangely, we still have some bars open in some states here, which is somewhat mind-boggling. But yes, as I said, thanks for taking the time. I hope all of you in the audience enjoyed this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS, we are a not-just-for-profit company. If you enjoy our free webinars and feel that they demonstrate solid insights into the kinds of testing challenges you face, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. Happy to provide a quote for any such help you might need. You can contact us, info@rbcs-us.com. And I'll add that we do work in partnership with Adam, and particularly on the training that he talked about. So feel free to contact us for that here in the US. All right, so that said, thank you all for attending, and see you at the next webinar.